in integration topic.
This method, the method to find a solid volume of something.
Ah, for me, one of the methods that used by engineering.
Yeah, all of your responses are correct, guys. You are very smart. So now let's continue about the definition of the this method, and also we will find the formula of the this method. The definition and formula of this method. What is the this method? The this method is a method to find the volume of a solid of an evolution. These are the example of solids and its axis of revolutions. That is the axles, funnels, peels, bottles, and pistons, where we can use the this method to find its volume. From the example, we can see that when a region in the plane is revolved about a line, the resulting solid is a solid of revolution, and the line is called the axis of revolution. The simplest such solid is a right circular cylinder or disc, which is formed by revolving a rectangle about an axis adjacent to one side of the rectangle, as shown in figure 7.13. From the picture left, we can see a rectangle on the disc. Then we can take out the rectangle so that it becomes like in the picture in the right side. Now we are going to determine the formula of the this method to find the volume of the solid. Volume of this equal to area of this times width of this equal to pi r square w. We know that the disc is like a circle, so that the area of a circle is equal to the area of the disc, so that pi r square we put as the area of disc, where r is the radius of the disc and w is the width. Then approximating the volume of the solid by n such disc of width delta x and radius r xi produces volume of solid equal to sigma start from 1 to n pi r respect to xi square time delta x equal to pi sigma start from 1 to n r respect to xi square time delta x. Then you can see on the screen that this method representative. So this approximation appears to become better and better as dome of delta approaches zero, that is, and approaches infinity. So you can define the volume of the solid as volume of solid equal to limit dome delta approaches to 0 pi sigma start from 1 to n r respect to I square time delta x equal to pi integration start from a to b r respect to x square dx. Then we can see in the schematically on the screen for the picture as the concrete figure to define this method formula. Also, the formula transition from the volume formula to the new integration formula that we call it as the this method. So start from the pre-calculus formula and then representative element, and the last one, new integration formula. So here is the formula of this method. The formula divided into two parts. That one, horizontal axis of revolution, and the second one, vertical axis of revolution. So for the horizontal, volume equal to V equal to pi, integration of start from A to B, r respect to x squared dx, and for vertical axis of revolution, the volume equal to V equal to pi, integration start from C to D, r respect to y square dy. So on each formula we can see the figure that about the horizontal and vertical axis of revolutions. However, there is something that I think all of us curious to know. So I think it's about the role of all of this in the real world.
Okay, we will continue to integral in the real world. So what is the application of the integral? The first one, we can determine the area of under curve or the area between two curves. And this is the graph of area under a curve. And the second one, we can find the volume of a solid of revolution. So when we revolve the area to x-axis, it will result the solid, and we can find the volume of the solid using integral. And the third one, we can find the centroid of an area. The next one, in electrical engineering, integral is used to determine the exact length of a power cable to connect two substations which are miles away from each other. And the fifth one, we can find the force of an area in a depth of a liquid.
Okay, after all the explanation about this method and the use of that in the real life, here is one of example of problem solving using this method. The problem is about volume of a full tank. A tank on the wing of a jet aircraft is formed by revolving the region bounded by the graph of y equal to 1 over 8 times x squared times the square root of 2 minus x, and the x-axis is about 0 smaller and equal to x and x smaller and equal to 2, x-axis, where x and y is measured in meters. Use a graphing utility to graph the function and find the volume of the tank. First of all, I would like to show you about the graph of the function and rotate to x-axis from 0 to 2.
This is the visualizations of the problem. We use the Math 3D online 3D graphing calculator with the website link math3d.org. Moreover, we can set a lot of things related with visualizations of the graph here, such as rotation axis, inner and outer surface, also axis and camera.
So, from the animation before, I hope you can visualize well about the function that we will solve using this method. Here is the formula. the integration of pi times r squared dx starting from a to b. Then, from the problem, we found the form like the integration of pi times 1 over 8 times x squared times the square root of 2 minus x to the power of 2 dx starting from O to B. So first, let we count and we solve the indefinite integral first. And we found that P is constant, so we can take out from the integration, so we get pi times the integration of 1 over x squared square root of 2 minus x to the power of 2 dx. Then we could change the form of this to the 2x times the square root of 2 minus x over 8 to the power of 2. Then we simplify this one and we could find that x to the power of 4 times 2 minus x over 64. Then we simplify this again to be 2x to the power of 4 minus x to the power of 5 over 64. So we know that the form of this is 1 over 64, right? So 1 over 64 is constant. We can take out also from the integration. So we know, so we get pi times 1 over 64 times the integration of 2x to the power of 4 minus x to the power of 5 dx. Then we multiply this one and spread the integration of this. So we get pi over 64 times the integration of 2x to the power of 4 dx minus the integration of x to the power of 5 dx. So we calculate the integration. It's going to be pi over 64 times the integration of 2x to the power of 4 is gonna be 2x to the power of 5 over 5, then minus the integration of x to the power of 5, it's gonna be x to the power of 6 over 6. So we calculate and simplify this one. It's gonna be 12 times pi x to the power of 5 minus 5 pi times x to the power of 6 over 1920. So until here, we already can return the limit, which is starting from 0 to 2. So we get 12 pi times 2 to the power of 5 minus 5 pi times 2 to the power of 6 over 1920 minus 12 pi times 0 to the power of 5 minus 5 pi times 0 to the power of 6 over 1920. We simplify this and we get 12 pi times 32 minus 5 pi times 64 over 1920 minus 0 over 1920. Then we simplify this again and we get 384 pi minus 320 pi over 1920 minus 0 over 1920. Then we simplify this again to the simpler form. So we get 64 pi over 1920 minus 0. So 64 and 1920, it can be divided, like stretch. So we get the simpler form, that is pi over 30.
To sum up, the Dix method is one of the topics in integral calculus as a method for determining the volume of a solid by dividing the solid into many smaller parts. The Dix method is easier to use for its application to solve problems with the solid rotating on the x-axis.